So next question is, a particle is projected at time t is equal to 0 from a point P on the ground with a speed v0 at an angle of 45 degree to the horizontal. Find the magnitude and direction of the angular momentum of the particle about a point P at time t is equal to v0 upon g. In this case, we are supposed to find out the angular momentum. First, we are going to draw the figure. So a particle is projected from point P. Let's suppose this is the trajectory with the initial velocity of v0 making an angle of 45 degree, and suppose it reaches this point, that is point Q, after t, and this will be the its velocity component. Let's join this PQ and call this as R. So this will be x direction and this will be y direction, and let the component of Q is x comma y. So its horizontal component will be Vx, and let us call this as Vy. So initial component horizontal, that is u of x, will be equal to v0 in x direction, that is v0 cos of 45, and initial component of velocity in y direction will be equal to v0 sine of 45. So let us call Vx as final velocity horizontal component at point Q, and Vy is final velocity vertical component at point Q, and acceleration in vertical direction will be equal to minus g. So in horizontal direction, ux is equal to v0 cos of 45, we already mentioned it, cos of 45, and distance traveled, if it is x, will be equal to ux multiplied by time t, and this will be equal to v0 cos of 45 t. Now in vertical direction, Vy is equal to uy plus a by t. So uy is v0 sine 45, ay is minus g multiplied by t. This is Vy, and distance, let us call this sy, is equal to u by t plus half a by t square. So this will be y is equal to uy is v0 sine 45 multiplied by t minus half g t square. Now we are going to find out the angular momentum. So angular momentum can be found out using the cross product also. There is another way. So angular momentum of the particle at q, whose coordinate is given by xy, about point p, whose coordinate is given as 0, 0. This will be equal to m vy multiplied by x minus m vx multiplied by y. So we take m as common and substitute value of vy, x, vx and y. So we get v naught sine 45 minus gt. X is v naught cos 45 minus vx is v naught cos 45 and y is v naught sine 45 multiplied by t minus 1/2 g t square, all bracket closes. Now we also know that time it is given the question that time is equal to v naught by g. So it's given the question that t is equal to v naught by g. So we can substitute the value of v naught, t is equal to v naught by g. So we will getting this as m v naught sine 45 is root 2 minus we get g into v naught by g, v naught square root 2 minus v naught square root 2 and v naught square root 2 multiplied by t, t is v naught g minus half g t square, that is v naught square upon g square, and bracket closes. So if we solve this, we are going to get this as the final answer will be equal to minus 2 square root 2 m v naught q upon g. So this will be the angular momentum of particle at g, whose coordinate are given x, y, about p, whose coordinate are given as 0, 0. Now we are supposed this is the magnitude, and we are going to find out what will be the direction. So for the direction, we can say that the direction first of all will be perpendicular to the r. This is r. First will be, it will be perpendicular to the r. Okay, so we can write it like this: direction you can say direction will be mutually perpendicular to the distance r, direction will be mutually perpendicular to the distance r and momentum vector. Secondly, the direction will be along the normal, will be along the inward normal, inward normal to the plane of the paper. So we get it will be mutually perpendicular to the r and it will be normal to the plane of the inward normal, inward normal to the plane of the paper. Thank you.